So friends, in this video we'll be doing methods of charging. So let's get started. By friction. The first method of charging is by friction. Obviously we are charging the objects. Okay. So by friction or by rubbing, the method is usually used for insulators. Bodies having more phi will take the negative charge from the other. Obviously when we rub two objects, let A and B, and phi of A is less than phi of B is greater, so after rubbing it will take its negative charge and left some positive charge on A. Okay, whoever phi is greater will take the electrons from the other object. Obviously decrease and increase in mass is same for the bodies. Mass of B will increase and of A will decrease. The example is silk and glass. When you rub silk with glass, glass acquires positive charge and silk acquire negative charge. There are some type of plastic which when rubbed with silk, this is some type of plastic, it acquires negative charge and silk acquire positive charge. So it is not universal that silk will always acquire negative charge. Depending on the other material, we can say they will acquire charges. If initially they were neutral, both will acquire equal and opposite charges. Okay, so obviously you need to rub against each other because they are not conductors. The other method is for conductors. That method is called conduction. Two conductors are just touched or connected by a conducting medium wire or conducting medium or conducting wire. You need not to rub them. The movement of charge is almost instantaneous. Okay, it is almost instantaneous. The charge will automatically flow from one object to another and they exchange their charges till both reaches a common potential. Okay, this is a new term for you guys and we will be discussing this in the upcoming videos. So just listen to that. Till the moment they reaches a common potential, the charge will continue to move, and when they reaches a common potential, charge will stay or stop flowing. Potential energy is lost from in the form of heat due to the flow of charge. Whenever charge flows from one object or one place to another, obviously due to some resistance of the conductors, heat energy is lost and potential energy of the system decreases. Flow of charge stops in a minimum potential energy state. If conductors are identical, obviously the final charges will be same. This is an important statement, should be remembered, that the final charges will be same if the conductors are identical in shape and size, even though initial charges are different. Let us solve a simple question. Three identical small conducting spheres ABC have charges 12, -6, 0. Find the final charges on each after these following steps. A is touched with B and then with C. Okay, so I'll just draw the initial state A, B, C. This is 12, -6, 0. After the first part, A is touched with B. A, B, C. A is touched with B. The total charge on A plus B is +6. So they will share equal charge. +6 by 2 means +3 and +3. This will have 0. And after the next step, then A is touched with C. The total charge is 3. So after the final part of the step, it will have +3 by 2. B will have 3 because it is no more in contact with anything, and C will also have 3 by 2. Okay, so when the next part is B is touched with C and then with A. From the initial state, B is touched with C. The total charge on this setup is -6, and when they touches each other, both will share equal, the -3 and -3. A will have 12 coulomb and then with A. B is then touched with A. So the total charge on BA system is 9 and they will share equal, so 9 by 2 and 9 by 2, and C will have -3. In the next part, C is touched with A then with B for infinite times. Okay, so we are taking C, touching A, then B, then A, then B, then A and B. So by doing infinite repetition among themselves, final charges on each will be equal, and after many repetitions we can say final charges on them will be equal, and that is 1/3 of the total charge on the system, which is +6. So +6 ka 1/3, 2, 2 and 2 will be the charge on each after infinite number of repetitions. Okay.